Welcome to an introduction to statistics, brought to you by Parkbench Tutors and narrated by David Hopcroft. For more information about Parkbench Tutors, please visit parkbenchtutors.com. In this podcast, we shall give you a brief introduction to statistics. We advise that if you are uncertain, then you should stop the podcast and replay that part. If you still find difficulties, then leave a message, and if we can, we will respond. Statistics is about what we do with data that has been collected. So it means we are looking at how we collect data, how we sort data, how we try and analyze, and how we present the data. A simple list of data that has been collected has little use. If we have a list of people with shoe sizes, then it only starts to make sense if we sort it, say into frequency of shoe sizes. Of course, we could sort by the names of the people according to the letter of the alphabet their name began with, but it is not likely that this would be of particular use. The simplest method of displaying data is to group the data so that data is displayed as a table. In this case, we are looking at the frequency of shop types in a particular area. We can present the same data in a bar chart, which gives us a different visual picture. These charts make it easier to get a picture of the relationships, but they also sacrifice a degree of accuracy when we do this. Data collected can be described as either quantitative or qualitative. If we are making a measurement, whether it is of length, time, amount of money, or mass, then we are collecting quantitative data. On the other hand, if we are collecting data on colour of eyes, or of hair, or of our favourite soccer team, or what we do for a living, then this is qualitative data. It is important when collecting quantitative data that you understand the difference between discrete and continuous data. If you measure something that can only have certain definite values, then you have discrete data. In counting the rooms in a house, then you can only have definite values. You either have a room or not. You cannot have half or a third or 100th of a room. With continuous data, this is not the case. If we measure the time taken to walk to work, then, in theory, the number of possible values is infinite. In order to make sense of these measurements, we will often group them. We say that we assign the data to a range. We must also accept there can be problems when we try and measure qualitative data. In some instances, the values can be defined easily, so that if we are counting types of plant or types of bird, then we can do this by identifying the species of each specimen. In contrast, if we are determining the colour of hair, then this becomes subjective. It is unlikely that we will all agree on what is brown hair, dark brown hair, and light brown hair. The list of data is referred to as the raw data. Here the raw data tells us about the number of pairs of shoes owned by a sample of people. If we group these into a table to tell us the frequency of the number of pairs of shoes, then we have sorted the data and presented it in a different form. This sorting and presenting of data is an important part of statistics. Suppose that we have continuous data, in this case data on height. In order to group this data, we sort a little differently, into ranges. We can then set out the ranges as a table. Using data in this way requires that we define a small number of terms. Each particular class or range will have a class interval. The lowest value for each class is termed the lower class limit, and the highest value for each class is termed the upper class limit. The class boundary is a little different. For discrete data, we define the class boundary as the point midway between the lower and upper class limits of adjoining classes. For continuous data, we take the smallest and largest values that we could obtain in theory. So if we are using 1.99 as the upper class limit of one class and 2.00 as the lower class limit of the next class, then the midpoint becomes 1.995. Finally, the length of a class is the difference between the two class boundaries. You will soon encounter the question of class width when you are looking at tables. If you look at this table, you will see that the first and last classes are different. They are of a different size. Whilst most of these have a class length of 5, the first has a class length of 10, and the last would depend on a definition of a small farm so that we could fix an upper limit. We have taken this to a different level here, making each class different, not only in terms of size but also in terms of definition. Whilst this type of data can be informative, the analysis is going to be limited. It appears that smoking carries a high risk of shortening a lifespan. We could not quantify risk from this sort of data. Newspapers often present data in this way, and you should look carefully at how the classes have been selected. Here we have data relating to obesity on a sample of a population. A population means all the persons in a group. A sample means that we consider only some of these, and we need to ensure the sample is representative. We will return to this in a future podcast. The frequency is shown and the total of persons in the sample. What else can we do with this data? We can express the relative frequencies in terms of proportion or in terms of percentage. This can be useful when the numbers for relative frequency become very large. Let us look closely at presenting data. Here is a table relating to the observation of birds in a country park. The frequencies are shown for each type of bird. This type of information is easily presented in the form of a bar chart. Note that with a bar chart we separate the bars to show the classes are isolated. Now consider the frequency distribution for height from a sample. Here we can see that the data is related in another way. The presentation needs to show the relationship of this data. So we use a histogram to present this data, where there is no separation of the bars. We often use a program such as Microsoft Excel to draw our charts, and you should ensure that you are familiar with the techniques of drawing bar charts and histograms. You will see data presented in this form, which we have already noted has different class widths. We will suppose that the data is related and draw a histogram. What now happens is that the presentation is distorted, because the visual impression is of classes of the same size. For example, the frequency for 11 to 20 seems higher than that for 1 to 5, but class sizes are not directly comparable. We need to make a correction for this. To do so, we perform a simple piece of maths called determining the adjusted frequency. The adjusted frequency is to take minimum class size and divide by actual class size, then multiply by the original frequency. The results are shown in the end column of this table. Using the adjusted frequency, we can see that the frequency for 11 to 20 is actually below that for 1 to 5. What we have done is to make the area on the histogram proportional to the frequency of the class. This is an important adjustment if you are trying to interpret data from a histogram and you see that the class widths are different. A set of data presented as a histogram can also be presented as a frequency polygon, where we use the midpoints between two classed boundaries. The table shows the calculation of midpoints for the classes. Here we have constructed the histogram and the frequency polygon on the same chart. This can be done fairly easily using Excel. Adding up the frequency at each stage gives us a measure called the cumulative frequency, and this is used in statistics. Once we have determined the midpoints, then we can construct a cumulative frequency polygon. The cumulative frequency here is shown in the end column on the right. And here is our cumulative frequency polygon. When you plot frequency polygons, or many other charts, you will come to recognize common shapes. These are important because they provide clues on interpretation of data. Here are a few of the common shapes to look for. A bell-shaped curve is usually symmetrical. The shape may be skewed to the left, in which case we say it has negative skew, or skewed to the right, in which case we say it has positive skew. You will also encounter J-shaped curves with a maximum at one end. Just as we can present frequency in terms of proportion and percentages, so we can present the frequencies in terms of degrees, where the total has to add up to 360 degrees. We can then present the data in the form of a pie chart. We will say more about using pie charts in another podcast. This ends our introduction to statistics, brought to you by Parkbench Tutors and narrated by David Hopcroft. Thank you for watching and for listening. We wish you success in your studies. For more information about Parkbench Tutors, please visit parkbenchtutors.com.